This is page 10 of our chapter 4 notes for Math 110. The first example at the top of the page says, though a manufacturing error, 3 cans marked regular soda were accidentally filled with diet soda and placed in a 12-pack. Suppose that 3 cans are randomly selected from the 12-pack. Part A says determine the probability that exactly 2 cans contain diet soda. So probability, exactly 2 cans contain diet soda. Again, pause the video, reread the problem, make sure you understand what it's asking. Since we are selecting cans, it does not matter which order that we select them. You can either open them up 1, 2, or 3, 2, 1, 3, and so on. So order is not important on this one. So order is not important. And we also know that it says that there's a total of 12 cans. And from this, we know that 3 are diet. And that means that since it's 12 cans total, 3 diet, that means that 9 are going to be regular soda. And so in order to find our sample space, we're going to call that N. And since order is not important, we're going to be using combinations. So I'm going to put a C there. And out of all of the sodas that I can pick, there's 12 of them. And I'm going to be choosing 3. So that's going to be our sample space when we do our probabilities. So for the first one, it says determine the probability of exactly 2 containing diet. So with that said, that's going to be 2 are going to be diet and 1 is going to be regular, because remember, we're selecting 3 soda cans. So again, probability that 2 are diet and 1 is regular. So again, I'm using D for diet, R for regular, and that capital P is for probability. Since I am doing a probability, I know that my sample size, which is N, is going to go at the bottom. And then I'm going to split this. I'm going to call the first one diet and the second one regular. And since we're dealing with order is not important, those are also going to have C's for combinations. The word and stands for multiplication, like we saw before. Diet total that we have is 3. And we are going to be selecting 2 of those, since the problem says selecting exactly 2. And then that means that out of the 9 total regular, you're going to select only 1 of them. And so if you put this all in on your calculator, so try it out, you should get 0.1227, rounding that 4 decimal places. So part B says determine the probability that exactly 1 contains diet. So that means if 1 is diet, that means that 2 would be regular. And again, remember, we are selecting 3 soda cans total. So this is going to be 1 diet and 2 regular. So again, since it is a probability problem, I'm going to go ahead and draw in my fraction line there. That denominator is still going to stay the same, since this is the same problem, the same selection. 3 cans we're selecting from those 12. And then again, I'm going to look at diet and regular. Go ahead and put C's above both of those for combinations, since order is not important. Total diets we still have in our possibility is 3. This time we are selecting 1. And means multiply. Regular sodas that we have a total of 9 of those, and we are going to select 2 in this problem. So again, the problem was exactly 1 contains diet, and therefore 2 are going to be regular. Again, working this out on your calculator, so pause the video and try to work it out. Around 4 decimal places, we get 0.4909. Part C says determine the probability that all 3 contain diet. So that means that 3 are going to be diet, and that means we would have 0 regulars. So this time again, probability that 3 are diet and 0 are going to be regular. Same idea. Again, pause the video, try to do this all on your own, and then check to see if you did it correctly. We should have 12, choose 3 for our denominator. Again, splitting this up as diet and regular. C's above both of those, since order is not important. we had a total of 3 possible cans that we can select our diet, and we selected all 3 in this problem. And means multiplying. Regular, we have 9 total, and we're going to select 0 of those. Working this out, the probability of selecting all 3 diet cans randomly is going to be small. So 0.0045. The example right below this says, suppose that you have just received a shipment of 100 TVs. Although you don't know this, 6 of them are defective. And again, we had 100 TVs total. To determine whether you will accept the shipment, you randomly select, so you're going to select 5 TVs and you're going to test them. If all 5 TVs work, you're going to accept the shipment. Otherwise, the shipment is rejected. What is the probability of accepting the shipment? So again, in order to accept the shipment, that means that it says you're going to be selecting 5 TVs, and if all 5 TVs work, so we'll say 5 have to work. So we have to find the probability that all 5 are going to work or be good, and 0 of those 5 are going to be defective. So for this problem, order also does not matter because we are just selecting these 5 TVs. It doesn't matter if you have TV 1, 2, then 5, then 4, then 3. So order is not important. We also know that you have a total of 100 TVs. From this, we also know that 6 of those TVs are going to be defective. So 6 are defective. And if 6 of them are defective, that means 94 are going to work. They're going to be good TVs. And so our sample size again is going to be out of those 100 TVs that we have. For this testing, we're going to select a total of 5. So 100, choose 5. Again, C is there because this is a combination problem since we said order is not important. So going ahead and fraction line, putting our denominator in, which is our sample size, which is 100, choose 5. And then we're going to split the numerator into those 2 groups that we have, working and defective TVs. C is above both of those since they are combinations, since order is not important. Total amount of working TVs that we have is 94, and we want to select all 5. Again, and means multiplication. Then defective TVs, there's a total of 6. And we are going to select 0 of them in order to accept our shipment. Working this out on your calculator and rounding 4 decimal places, we get 0.7291. The last example on here says Todd is putting together an exercise routine and feels that the sequence of exercises can affect his overall performance. He has 12 exercises to select from, but only has enough time to do 9. How many different exercise routines could be put together? So first of all, I want you to notice that this problem does not say anything about probability. It's asking for how many routines that we can come up with. So I want you to first realize that your number answer would be a large value. It's not going to be a small value, like probabilities are between 0 and 1. And since he believes that there's a special sequence of exercises that can affect his overall performance, this exercise routine would change depending on the order. And so we're going to go ahead and say that Todd believes that order for our working out is going to matter. And so from that, we know that we are dealing with a permutation, which is where order matters. So I'm going to put a P there. And the total amount of exercises that he can select from is 12. And he's going to select, it says, and he only has enough time to do 9 of those. So 12, and we're going to pick 9 of those. And on your calculator, you should get 79,833,600 different exercise routines. So that's how many routines he can come up with in an order, specifically with 9 exercises from those possible 12. So please let me know if you guys have any questions with these, and stop by office hours or email me if you have questions.